Everybody, we are going to start looking at the next two examples in chapter 7, lesson 4, dealing with radicals. So, example 4 on page 421, and I'm going to post the book resource for you guys to look at to go along with this. So, this is about rationalizing a denominator. So, what they mean when they talk about rationalizing is let's just dive into an example and then you'll see what they mean. So, if I have this square root of 35 over 15, the first thing you do is you simplify it while it's under the radical sign, and that gives you 7/3, right? You divide them both by 5, and you get 7 over 3. The problem is they don't like it when you leave things with a radical sign where it is in the denominator. Now, you might be saying, well, it's not in the denominator, there's a fraction there. But if we look at it like this, if we say we're going to rewrite this, and again, I apologize if my writing isn't the best, um, as this, which is what this is, we do have a radical sign. We've got one right there. It's in the denominator. They don't like that. So there's a really straightforward way of getting rid of radical signs. So what I know is I can do anything to a fraction as long as I do the same thing to the top and the bottom. So what I'm going to do is I'm going to take this fraction, I'm going to rewrite it here, and then I am going to multiply both the top and the bottom by what's on the bottom. So I have square root of 3, so I'm going to multiply this whole thing by the square root of 3 on the bottom, and because I'm doing it on the bottom, I'm going to do it on the top. And you get the square root of 3 on both. So now the hardest part is just figuring out how to simplify this. So 7 times 3, we're going to put that whole thing under the radical sign. So that becomes 21. And then the square root of 3 times the square root of 3 is just 3. And the reason that is because if you have the square root of 3 times the square root of 3, that gives us this. And that's the square root of 9, right? And the square root of 9 is 3. Now, this answer right here is okay because it's simplified and it does not have a radical sign. So let's look at another one. Square root of 6y over the square root of 12. So first things first, simplify it, right? So if you do that, you get the square root of y over 2. And now notice I didn't write the 1 because we don't have to do that if there's already something up there. The only reason you would put a 1 up there is if there's nothing else up there, so it's almost like a placeholder. But we do have something up there. We have the y, so let's get rid of that 1. So you have y over 2. So that breaks down to splitting it apart to this. And then what we discussed on this is we don't want a radical sign down here, so we're going to take this and we're going to multiply both the top and the bottom by what's on the bottom. So the square root of 2. Okay? So then, simplifying that, you'll put y and 2 together under the same radical sign. Wow, I'm getting a little wild here. Y times 2, and then that goes over square root of 2 times 2, which I know for the bottom is just 2. Basically, if you multiply a square root of something times the same square root, you're just going to put what's under the square root as your answer, and then at that point you lose the radical sign. This one, the top, is going to stay under a square root sign, and convention is to always put the number first and then put the variable second. So our coefficient is 2, our variable is y. So it's the square root of 2y over 2. I notice I can't simplify this 2 and this 2 because this 2 is under a radical sign. This one is not. Okay, if this were outside the radical sign, I could simplify them, but it's not. All right, try this one on your own. This one looks a little trickier than it really is. So think about this, all right? I'll get you guys started. You've got square root of 27 over the square root of m to the 5th. So think about how do we simplify the square root of m to the 5th. And then when you come back, I will look at this with you. All right, so I hope you wrestled with this a little bit because this is definitely different from what we just looked at. Hopefully you made the connection that the top you can simplify that to 9 times 3, right? So that gives you, on the top, that gives you 3 times the square root of 3. All right, hopefully you got it to that. And then hopefully you figured out that, hey, I can change this to m to the fourth times m. And we know that the square root of m to the fourth from what we've done in, I believe, example 3 is just m squared on the bottom. And then the square root of m stays under. So now this is an example of where we are going to multiply something by the top and the bottom, but I'm not multiplying it by everything that's under here. I can leave the m squared down there. They're totally cool with that. What they aren't cool with is that square root to the m. So what I'm going to do now is I'm going to take this, I'm going to rewrite this, and I'm going to multiply the top and the bottom only by this, only by the square root of m. So let's do that. Square root of m, square root of m, and then that gives me 3 times the square root of, well, I got 3 and I've got m under the radical sign, so 3m. It's kind of funny hearing that. They're the ones who are behind making all the masks and everything that everybody needs right now. And then you have m squared, which we are then going to combine with, well, the square root of m times the square root of m gives us another m. So if I have m squared and then another m, that is going to give me m to the third power. And if I did that kind of quickly, I'm just going to write it out for you. So it's m squared times the square root of m times the square root of m. These two combine to give you an m, right? So you have m squared times m. That has an exponent of 1. And then just add your exponents. So that is how we got to that. So hopefully this was helpful. I don't know what the examples on ALEKS are going to look like, but I'm having an idea that they're going to be kind of mixed and have variables and numbers in them, which is good because that's generally speaking what you're going to run into. So good luck with these, and again, feel free to reach out to me if you need help.